Hey there, CS210 students. So this is part 2 of Chapter 2's overview. Last we left off in Chapter 2, Part 1, we were talking about integer division and the fact that when you divide two ints, you get a integer value back, and you're going to lose the decimal portion of the number. So the reason that is when you're doing arithmetic in C++, the data types are going to dictate what you get back. So if you're dealing with integers, regardless of if it's addition, subtraction, any of the arithmetic operators, two integer values are always going to return an integer value. If you're working with two doubles, you're going to get a double value and so forth. So what happens if you mix the types? So C++ does handle some implicit conversion. So this is handled for you. This is an automatic type of conversion. And the idea with this is that if you have any type of double mixed in with an integer value, that's going to be the highest level. So things are going to be treated as a double. So for instance, if I were doing int and a double doing addition, the int is going to be treated as a double because I can handle that straightforward. 25 can become 25. It can be promoted up. And so the result would then be adding a double with a int that's been implicitly treated as a double. And so you're going to get a double in the end. The reason that programming languages do that is they don't want to do a downward conversion. So if I were to go from a double to, say, an int, then we're going to lose the fractional portion. And typically in arithmetic, you don't want to lose any precision. So doing this in arithmetic is going to be detrimental. Now, there might be some cases where, yes, you want to only have the integer portion of this. So treating it as an int might be your option. But just keep in mind that the consequence of working with different data types is going to be depending on what you get back. And then the last thing that I touched on in the integer division was that to handle that properly, you could treat one or both of the values as a double. So if you're dividing by the number 4, you could, instead of writing 4, write 4.0, and then it's going to be treated as a double. But C++, just like other programming languages, also offers ways of assigning the data type, or treating the data type, and that's by casting. So we can explicitly typecast what we want something to be treated as, and we use the static cast operator. And so we go static cast, and then the data type. So in this case, they've got a double example, or it could be an int, or whatever data type you want to treat it as, and then the expression inside the parentheses. So the example is right here, static cast double. So we're going to treat whatever's in my int variable as a double. So it's going to be returned back as a double. So here's a good example of why we would want to do that. So if we want to do some division where we're going to determine the average number of kids per family, so this is always going to be a double. So treat it declared as a double. So we've got an integer for kids in family 1 and family 2, and then the number of families. And to get the average kids per family, we're going to take the sum of those two variables and then eventually divide by the number of families we have. But see that they're treating that numerator as a double. They're applying the static cast as double operator to this entire operation. So this numerator is a double. This denominator is also going to be treated as a double. So now behind the scenes, it's going to be double divided by double. That's going to return a double back. So that's why this variable is declared as a double. And we're not going to lose any of the precision that we would have lost had we not statically casted these. So my rule of thumb is this: if you have a literal number, so if you have a hard-coded value for number of families, not this variable value, but if I had 2 here, then you could just treat that as 2.0 and handle the arithmetic that way. But when you don't explicitly know what the values are going to be, then you do need to apply the static cast operator. Okay, let's go to section 14. And in section 14, we are talking about the character data type. And we're just briefly going to introduce it here. We're not going to do a whole lot with characters. But to declare a character type, you're going to go char or char, variable name, and then you use single quotes to declare a character data type. Just like with integers and doubles and floats, you can see in those values. So we can see in and use the extraction operator and assign it to the data type. And then one thing I want to mention to you, typically under the hood in every programming language, characters are stored also as a number. So some kind of mapping exists where A maps to some number. So in this case, they're saying A maps to 97, and then it's contiguous after each letter. They are then in a numerical order. Let's move into section 15, and we introduce having string variables. So a string is a sequence of characters. So hello and 52 Main Street and 42, these are all strings, and we know that because they're wrapped in double quotes. So keep in mind that 42 as a string with quotes is different than 42. This would be an integer value. This is going to be a string value. So you can declare your string variables. So we can declare our strings. We have to include the string. So have the include string statement. Now we can declare string types. We can declare them. We can assign values to them. We can see out them. We can also use cin and assign them to input. So just like this, we cin and assign them to variables. And then this section also brings up the getLine function. So the function getLine takes cin, takes a string variable, and we get all the remaining text on the current input line. So how you get string input is kind of up to you. I'll leave that to however you want to do that. Okay, let's jump to section 17, and we've talked about some of these different types. We've talked about a character, we've talked about an int, we've talked about double and long, but C++ has many different types of data. So a character has a size of 8 bits, so it uses a sequence of 8 zeros and ones, and it can represent values in the range of -128 to 127. Shorts, longs, long longs, and ints, these are all available to represent integer type values. The difference being is their size in bits, and they're giving us kind of the standard size, minimum size. This is kind of the typical representation of how many bits they are. But a short with 16 bits has this numeric range. A long with this amount of bits has this numeric range. And as you can see, the more bits you have, the bigger values that you can store. Floating point numbers. So we have a float and we have a double. And so the idea with this is that a float is 32 bits. And here's the supported number range that it can hold. And then a double, the reason it's called a double is because it's twice the size in bits of a float. So with 64 bits, it can represent numbers in this numeric range. And there's also, not only does it hold a bigger value, but the amount of significant digits is also different. So for a float type, it can be accurate up to 7 significant digits, whereas a double is accurate up to 16 significant digits. And it has nothing to do with that twice the size thing. It's how the data type is represented under the hood using the sequence of zeros and ones. Okay, so let's go to the next section, which is section 18. And sometimes you may know that a number is always going to be positive. So you're going to want to use an unsigned representation of the variable. So unsigned shorts, longs, long longs, ints, and so forth. So same bit size, And here are the different supported number ranges. So basically it's the exact same number of values, you just get all of them going from 0 to the upper limit. Okay, so that's all of the data types that we're going to be working with. So now let's kind of change gears and let's talk about debugging and troubleshooting and figuring out when things are wrong. So let's kind of come down here and let's just take a look what we have here. We've got some code here. I'm going to go ahead and copy it and then I'm going to run this into Visual Studio. And yep, that's in main. So let's come in here and let's paste that here inside Visual Studio. Let's go ahead and delete out that comment. And so what I want to show you is how we can use the debugger to help us understand what's going on in our code. So the debugger is not going to help us figure out that we've left off a semicolon. The debugger is going to let us see the values of things as we progress through our code. And to do that, we use a breakpoint. So I come over here to the left of the numbers, and I click and I put a red dot. This is going to then, as the code executes, it's going to stop right here. It's going to pause, and we're going to be able to see the values of variables. Excuse me. So I'm going to put a breakpoint here on line 18, and we're going to run the debugger here. And so I'm going to see the text enter the circumference. I will enter in a circumference. So let's type in 10. And so now what I can do is I can hover over this variable value and I can see that it contains the value of 10. And they also provide some nice helper windows so I can come down here and see the current variable values here. I can also hover over it and I can pin it. So if I want to see it like right here, I can kind of slide these around. But this is great where I can see, all right, circle circumference, that is 10. Great, fantastic. And then when I do the next step of arithmetic, so I have got these steps right here, so I can step over. So now I'm on the next line and I can see that the circle radius has been calculated. It's 15.707, and I can pull up a calculator and I can do the arithmetic just like I've got it typed. And the value will be, I've got 3.14159.265. So great, I've got 1507.96325, and look, we've got the exact same thing down here. So this debugger lets me step through the code and I can see variable values as they happen. So for instance, we know that the circle area was 775, but then for whatever reason, we changed it to 999. So if I get some bad result out, so when I see at the console, so when I see circle area is 999 and I'm not expecting to see this, I can come in here and I can go through my code step by step. So as I mentioned, this is stepping over. This goes one line at a code. There's also step into. So if we were to come into any methods, then this would step into that method, and then you could step over the lines in there. And then this one right here, this is a step out. So this steps me out of a current method I'm in, and then it would return to the next line of execution. Most of the time, you're going to be using step over and step into. So really powerful tool that we can utilize to see what our variable values are and where things are getting evaluated at. Okay, last thing for this section, I do like that they have this style guide here. So I want you to understand that we want to utilize white space. We want to have each statement on its own line. While the compiler doesn't care about this, Python wouldn't like this, but in Java, C++, anything that's terminated with a semicolon, while this is perfectly legal, it just makes the code not readable. So each statement on its own line. Even though I can do this right here, this makes the code very difficult to read, so don't do this right here. Place this on the next line down. Next thing I want to point out to you, if you have braces, so every time you have an if loop or a while loop, you should always use the curly braces. So this wraps the entire functionality inside this if statement. So when A is less than B, then this code will execute. A common mistake is to do something like this. I'm just going to copy this. So a very common mistake is if we come in here and we don't utilize the curlies, and so I'm just going to see out a hello statement here. I got to have some variables, so int a equals 5, int b equals 6. So now I've got a and b, and so let's say I want to see out world. Okay, so if I'm kind of thinking, all right, so here's the functionality. So when I run this, this will give me hello world like I want. Don't need my debugging points. Go away. And so I can hit the continue and just run it. So what did we get here? So I get, oh, I returned out. Sorry. Let me move this. I'm surprised I didn't get a compiler warning on that. So I can see hello world. So that works as intended, but now let me make it so that the numbers are switched. And so this statement should not execute. So 6 is not less than 5. So this case, I get world printed out. So again, some of you are familiar with Python. In Python land, this is perfectly acceptable because it uses indentation. But here what happened is it evaluated A is not less than B, so don't print hello. But because this is not wrapped in the curly braces, this gets executed. So this is a common mistake that if you want something to be executed based on the condition, then wrap it in the curly braces. So my rule of thumb is this: as soon as I type a condition, I immediately type the curly, press enter, and then I've got the block taken care of for me. So they just talked about what I was mentioning right there. Always make sure that you use braces. Make sure, so we've got some naming conventions down here. Make sure that you're using camel case, starting with lowercase, and your naming conventions need to be indicative of what the variable represents. I shouldn't have to guess at what I is. Typically, a variable like I is just used to run through a loop, but don't use variables like I, J, K, A, B, C. You need to use variables that are indicative of their use. I know what maximum weight is. It's 300. User key. I get it. I know what that's probably going to be. Now, one thing that I'm going to differ on with them is that function names should not be camel cased, uppercased. Okay, we should not be doing this. You need to write it like this. The notation for a capital letter is going to represent a class that we've created, a data type. So we do not want to uppercase a function method. Do not do this. I will mention it in the rubric requirements feedback that I want you to be camel casing with lowercase your method. So ignore this right here. This should be scratched from the list right there. Okay, so that is it for this chapter.